everyone today for our GeoTalks Express session this afternoon. We're going to talk about an introduction to scripting in Global Mapper. Talk about Global Mapper script and run through some examples as well. I am Mackenzie Mills. I'm an application specialist here at Blue Marble. That means I work in the Global Mapper program every day. And this afternoon, I'm joined by Billy Noble, another application specialist. How are you doing today, Billy?
Doing great, Mackenzie. How are you?
I'm doing quite well myself. So before we dive into the content of today's webinar, we have a few just general housekeeping bullets to go over here. So about the webinar format, same as the past GeoTalks Express webinars. The attendees are in listen-only mode, so you guys can hear us, but we cannot hear you. If you do have any questions, we really do encourage you to ask those questions through that questions panel that you should see as part of the GoToWebinar setup. We will try to address some of those questions as we move through the webinar today, but if we don't answer a question, we will be responding to those questions via email after this webinar. And this webinar session is being recorded. It will be put up on our YouTube channel, and as attendees, you guys should receive an email with access to this recorded session if you want to go back and reference it or share it with colleagues. Some upcoming GeoTalks Express webinars that we have in the pipeline here. September 16th, 2 weeks from today, we will have a preview of our Global Mapper training program. We've recently moved our training program to be an online format, and so we'll just be previewing some of that and maybe get you interested in learning a little bit more about the Global Mapper program and how you can best use it. We are releasing a new version of the Global Mapper program this month. So at the end of the month, we'll be going through and showing what are the new features, what's new in Global Mapper, the new version, version 22. And after that, in October, we will be looking at what's new in the version 22 of the LiDAR module. A lot of new exciting stuff coming in that version. Of course, you can go on our website and look at the schedule for the GeoTalks Express sessions and register for the upcoming ones if they are of interest to you. So today we're talking about Global Mapper script. We are going to look at the basic structure of a script, talk about what Global Mapper script is and how you might be able to use it. We'll go over manually creating a script and talk about the connection of a Global Mapper script to a Global Mapper workspace file. We will look at currently supported script commands where you can find some help on those script commands where they're all documented. And we'll work through combining multiple processes, multiple commands in a Global Mapper script to perform a series of actions through this scripting. And we'll also look at applying some commands to multiple files, not just working with one data type or one data file, working across multiple. So to start off, we'll talk a little bit about what Global Mapper script is. Global Mapper script is an easy method to automate some processes in Global Mapper. So it's a text-based method. You create a script by typing in a text document. You list some commands with parameters to guide Global Mapper on what you would like to accomplish with this script. So it's a list of commands you're telling the program what to do via text as opposed to using the user interface. You can run a Global Mapper script through the user interface, or you can run it outside of the Global Mapper interface without having to open that viewer. We'll look at these as we run through some examples, look at how you would go about running a script. So why should you use Global Mapper script? Personally, I think that scripting in Global Mapper is underutilized. We do have some users that use it quite frequently to perform some repetitive processes in the program. As I said before, it's great for automating and increasing your workflow productivity, getting in some workflow optimization, and performing tasks like converting a file format or reprojecting data, doing some raster processing that you don't need to visually look at the data in the viewer to complete. So again, you should use the Global Mapper script maybe when you're completing processes that you know are going to work, that you don't really need to visually check on that data with the viewer until after the command has been completed. So Global Mapper script is fairly extensive. There are a lot of commands you can use with a lot of different parameters and options. We'll talk about some of those today, but you can always reference our scripting reference guide as part of the Global Mapper knowledge base for help if you're developing your own Global Mapper scripts. So to look at that, we do have our online knowledge base here, including our scripting reference section. It also is available in a searchable PDF form. And of course, you can access the documentation through the help menu in the Global Mapper interface as well. And this does include the scripting reference section, which details all the commands and parameters you could use in Global Mapper script. So before we jump in and start looking at some examples of Global Mapper script and what you can do with this functionality of the program, we did send out a link to download some data. So if you would like, you can follow along today. You should have received an email link to download this data, and it was a zipped folder called scripting data. In order for you to be able to run and execute these scripts and see the outputs generate, you'll need to place that folder on the root of your C drive. So you'll unzip the scripting data folder and place it at this file location on your C drive, the scripting data folder, and contained in this folder is all the data we'll be using today and, of course, our script files. Now, this has to be done because in some of these script files, we have named specific file paths, not only to our input data in these folders, but to this output directory. See scripting data output in order for you to see these outputs generate at this location with all of the scripts and the data. You should really place this folder at the specified location on your C drive. So you haven't done that already. If you'd like to follow along and execute these scripts with us, I do recommend doing that. And at this point, I think I will throw it over to my colleague, Billy, to talk more about the structure of a script and start looking at a few actual Global Mapper script files.
Sounds good. And let me just take over my screen here. Can you see my screen, Mackenzie?
Yes, I can. You're sharing it well.
Okay, awesome. So as Mackenzie said, Global Mapper script is simply a way to utilize Global Mapper, but through just a simple text document that you can write in many notepad type of programs like I have open here. So you can see how a Global Mapper script is organized. This top part here that says Global Mapper script version 1.0 is kind of a legacy command where you had to have the Global Mapper script as the first command, and this was the parameter version 1. But now, as I'll show you, a Global Mapper script can be saved as a .gms file. So if I go here, you can see my list of scripts that you guys also have. If you right-click on the file and go to Properties, you'll see this type of file is a Global Mapper script, so .gms. that's good to mention as well, because global mapper scripts are proprietary. All the commands are based for global mapper and global mapper only. This isn't like Python or other scripting languages. This is purely for global mappers use. Just so to go through here is the basic setup for a global mapper script is we have the first action is a command, which you want to do. And typically what many users do is import a file into the program. Instead of going to global mapper and going to open data files, or go to file, open data files here as well. In the script structure, the first command would be import file name. And I'll show you this in the next script that I have set up for actual scripts. And once you have, you've set up something like import file name or import file, you have a parameter and then equals a value. And typically when you're importing something, you'll want the parameter to be a file name. So there'll be file name and the location of whatever the file you have, like a shapefile or .dem or .tiff. And you can see that there's other parameters as well that can keep going if you want to define a shapefile as a specific type of feature. These are just examples that we'll show later on in the broadcast. And typically you can have multiple commands. Many users will have processing like editing vectors or creating grids. So that would be another command here. So for a simple one, you probably want to have an export, and maybe you want your parameter is to export a file type as maybe a KML file, and then have other parameters as well to define the export. And you can also include comments like in other scripting languages here. You can put a slash and just write what each parameter does, or what after each command does. What's very useful about global mapper scripts is that you can share these with other people, maybe in your workplace. You also have global mapper, and they want to run the same jobs as you are doing on your machine. You can just simply share this with another user, and if they have the right data, and they can execute these files. So enough of the script structure now, and I'll actually show you our first script, which is importing a file. So this is the very basic level of scripting in Global Mapper. It's the first action.
And as Billy said, importing is probably the most important and most used command, because you can't edit data or work with it unless you first load it, even via Global Mapper script here.
Correct. What I was going to show you guys is just that, yes, these Global Mapper scripts are .gms, but they can also be saved as .txt. They will work if you go to what many of the context is, going to file and running a script, and then choosing which file you want to load. Kind of also the other benefit of Global Mapper scripts is that if you have a specific workflow that imports a file and does some type of processing, and then you have a command that exports your file, you don't have to actually open the program to run it. You can simply, if I were to double click on one of these jobs, the outputs would be in the specific file directories that I directed it to. But yeah, well, I'll show examples of that later on. But yeah, for this first example, I have the importing a single file. So as stated before, this top level command here, Global Mapper script version 1, is no longer needed if you save it as a .gms. You can simply start with the import as your command and your file name with the equals, and then where or what file type you're trying to load into the program. You see I've created a comment here called "this imports an image file." So just to see how this,
sorry, yep. Just to note, Billy, the file path you have there is bounded with double quotations. Why would you need to do that in Global Mapper script?
that's a good question. Is it because of the spaces in between, or?
Yes, it is. If your file path has any spaces in it, Global Mapper will interpret that space as the end of the parameter value, but bounding that value in the quotes interprets it as a solid value, even if there are some spaces included.
Yep. And also, there'll be other types of parameters. So if you include a space, it says kind of going ahead, but if you had import, directory of files, this won't run because there's a space here. It needs not just this needs the what's that word, Mackenzie, for this character?
Underscore, I think.
The underscore. There we go. Yeah, the underscore. Yeah, in the command, that will make the command correct. And all the specific commands are in the scripting reference guide. So you can't start making up commands for the program. They all have to be within the, has to be something that Global Mapper recognizes. So the quotes, as Mackenzie answered for me, ends the parameter value as this is what the value is going to be. So let's not save that because I probably had an extra space somewhere. So I'll go to the File menu and Run Script, and I'll choose the imagery single import, and this will import an image into my workspace. And once you load the script, you'll see the script file preview here, just to make sure it's correct. And this bottom dialog will give you, processing notes if the script was successful or if it failed, if there was an error somewhere along the line. But I've tested this 100 times, so I'm going to click Run Script. And it imported the file of this JPEG 2000. So what if I want to load maybe more than just one? So I can do this by making the import command on multiple lines and just entering each file name that I know of that I want to import. So you could copy and paste import file name command, for 100 times, and then if you had each file name ready to go, you just copy and paste it right next to each equal signs. So to run this one, I'll go back to File, Run Script, and go to my multi-import scripting file here. And if you're following along, you'll see that in the script file preview here, it should be the same as it was in my document or my .gms file. And I'll just click Run Script, and I have 4 image tiles that load into the workspace. And since these are all JPEGs, and they're all the same file types, and they're all the same in one folder, I actually don't need to write every single file name. So this is an imagery directory import script. And this is a new command that I have for this script, and it's import directory tree. And the parameter you want here is to use a directory. And instead of going to a specific file, I'm going to navigate Global Mapper to import all the files and imagery tiles. So that's the subfolder where those JPEGs were in. And what should happen is it should pull in all those tiles that were in that folder. And this is becoming more of something that experienced users and companies use. If they have hundreds of tiles they've collected at a site or some type of work they've done, they can just simply drag and drop their files into the computer, and you want Global Mapper to load these all into one without having to specify each line. You just specify the folder directory. And I'll do the same thing here and go to File and go to Run Script and choose my imagery directory import script and click Open. And you see that in the script file preview here. It should be the same as it was in that document. And I can click Run Script. Kenzie, did I make a mistake here in my script? Oh, I did make a mistake because I have the wrong. Oops, sorry, guys.
No, well, you find the correct file there. That's good to note that when you're running a script through the user interface there, those script results will display any warnings or errors or unexpected values that the program runs into as it's trying to execute that script. So especially if you're just starting to write scripts, you're going through having to troubleshoot a little bit, running through the user interface as Billy is doing can help you find those problem areas in your script.
Yep, and I think it's because the directory was incorrect. And I'm trying to figure out where that was. And I think I just open it with Notepad and fix it really quick. And just file save. And let's try that again. So file, run script, imagery directory import. That's why it's good to make sure those scripting files were correctly on the root of C. So now if I click run script, there we go. Multi-image import. On the fly scripting brought to you by your application specialist at Blue Marble. Okay, and not just with imagery data, you can also do this with vector files as well. And for vector files, a common type is a shapefile. So going along the same lines as importing the tile directory, what I want to do here is just specify that I want to only load shapefiles. As you may know, shapefiles do come with a lot of other associated file types. These could be .prjs and .shx and other types. So I want to mask it so that it's only loading the relevant shapefiles in the folder directory. So again, import directory tree is the command, the parameter. The directory is where these shapefiles live in the scripting data shapefiles folder. And then I have file name underscore masks. And the space here is with an underscore. And the asterisk SHP file type is bounded by the quotations.
And that asterisk is a wildcard. So this is masking by that file extension .shp. If you were importing, another file with a prefix for specific file names, you could also mask by that with an asterisk on the other side of the mask there.
Yeah, that's the word I was looking for. The wildcard was the asterisk here. So just to see how this works in action, I'll go to run script and shapefile directory import. And I have the correct file location here. So I'm going to click run script. And I have the beautiful state of Texas here, outlines. And maybe you guys are familiar with using Global Mapper Workspaces. That would be, if you have files loaded in and maybe you change projection from the configuration menu and go to projection and change the projection here and you save a workspace. Well, essentially, workspace files are Global Mapper scripts. They're just saved as .gmws and not .gms. So I'll actually show you this in a Notepad. I'm going to open Notepad here, and this is a workspace file. Oh, sorry. So here's my workspace file that I had open. So there's a lot going on here. That's because when you're working in a workspace and make saves and have files loaded, and once you save, a lot gets saved to that file. Essentially here, a global mapper workspace saves with the global mapper script version 1 command, and I had some files loaded that you can see here. Import file name. So command, parameter, there's lots and lots of parameters for each of these files that were loaded. But essentially here, I have some more new commands down here, like define projection. So initially when I loaded this workspace in to create, it was in a geographic projection system, and I switched it to a state plane coordinate system. So once you change the coordinate system in Global Mapper and save, the workspace gets defined with the projection here with all the parameters. And there's more going along here, like map layout as well, map legend. But essentially, the idea here is that Global Mapper workspaces, function the same way as a Global Mapper script. And now, after I showed you this workspace, we're going to actually try and start exporting data. So that's the main crux of scripting, is being able to process or import files and then do processing and exporting all just through a text file.
So before we jump into exporting, we did get a question in asking about the different versions of Global Mapper in regards to scripting. And you can use a script that was written for an older version of Global Mapper, say version 19 or version 20. That script should run in the newer current version. We're on version 21.1 right now. If you write a script for version 21.1, we cannot guarantee that it will run in the older versions of Global Mapper, because we are constantly updating the program and adding new script parameters. So your script may include some parameters that have been added to the newer versions and are not present or recognized by the older versions of Global Mapper.
Yeah, correct. Great questions, guys. We will try and answer these. If we can't during the session, we will try and answer these at some point next week. They get sent to us in the tech support team to go over. We'll try and get those as quick as we can. But as I said before, I'll try and show you the script now with importing a file and then doing an export command. So as you've seen before, my first command here is going to be importing files, and I want to import those files that you saw of Texas. So import directory tree, and the directory will be those shape files, and I'm masking so only the shape files in that directory. And the second command will be exporting a vector, and I'll be defining the name of my new file as just a 1 KML file. So file name, and then the location, and the name, and the file type parameter. So type equals KML. As I said before, I don't have to have Global Mapper open to run this. So I'm just going to double click, and I'm going to go to that directory that was C scripting data output Texas. And there should be a KML file that lives there. So scripting data output Texas, and there it is, the regions file that was made at 2:29 p.m. and that was just right now. So I didn't cheat and had it there before. It actually did create the file, the KML file export. And I can also show an example of exporting imagery tiles as well. See if I can find my location here. So as I said before, very common workflow for more experienced scripting users in Global Mapper is importing imagery and maybe processing it overnight, maybe to a different type of file that's different from a JPEG. Maybe they export to GeoTIFFs or ECWs, and they have specific spatial resolutions, or they want to tile it out to smaller files. So for this example, I have the import file name, the JP2, and a second line export, the export raster command with the file name parameter. And here we have more variables that go along with exporting this raster. So we're sticking to the same type as a JPEG 2000, but a spatial resolution of 1 by 1, and grid type rows and columns. So we'll be gridding this in 3 rows. So rows 3 and columns 3. And as I said before, I don't actually have to open the program to see this happen. So if I just double click and then go to that location where I specified, which is the scripting data folder, and go to output, tiles, and my math is correct, 3 by 3 is 9. So there should be 9 files that now exist in your tiles folder. And since now my voice is getting tired, Mackenzie is going to go over a little more advanced settings in Global Mapper scripting.
Yes, so I'm going to jump back to reprojection, and we're going to look at a script that defines a projection to reproject some data. So in the script files folder here, I think it's script number 13, we have a script for reprojection. I'm going to go ahead and open this in Notepad. And we can see here, just like in the workspace that Billy showed us a few minutes ago, we have a projection defined. After we define that projection, we import a specific file, and then we load the projection. Now this load projection parameter references the projection name from our defined projection. And this is what changes that workspace projection like you would in configuration through the Global Mapper interface. And then after reprojecting this shapefile here, we are exporting it to a new file, and it will export using our loaded projection. So I can go ahead and double click on this script to run it, and this is running outside of the Global Mapper interface here. I haven't loaded anything yet, but if I go to our scripting data folder and look at our output folder, we can see this was our generated file. I can go ahead and load this in Global Mapper, and looking at the layer metadata, I can see that it indeed was reprojected and exported using that Lambert conformal conic projection that we defined in the script. So this is a really useful workflow to reproject some data. Again, you could use this operation on multiple files as well to reproject a series of files to a specific projection and export them to new files. While we're here, I'm going to go back to the scripting data folder, and included we have put the PDF Global Mapper scripting reference. And I'm just going to open this just to show you all of the different documented commands and parameters we have in this document. It's really useful. We use it all the time as we're building scripts or troubleshooting scripts. And this is a searchable PDF document, so I can use a simple Control F shortcut for this PDF to search for define projection. If I can type correctly. And this should come up with the define projection options here. It looks like my PDF reader is giving me a little bit of trouble, but I can go ahead and look in the online global mapper knowledge base as well to look at our define projection parameters, if I can remember quite where those are. Under display, we have our define projection, and you can see here some examples of the projection. And then the load projection parameter as well, where you can use a projection name from a defined projection, or you can define a projection and load it based on an EPSG code. So you don't have to include this whole projection definition.
So I think that does answer someone's question. They had, if they were able to, in a script, define a projection based on an EPSG code instead of the full parameters. And yep, you can see there back in that other page that you can with that projection EPSG code command.
Yep, as long as that code is recognized by Global Mapper, which they all should be, you can use that method to load projection to reproject some data via Global Mapper script as well. So if you want to take the screen back, Billy, we can move on to working further with a little bit of vector data.
Can you see it?
Yes.
Okay, great. Yep, so just a little simple thing I'm just going to show you here. So you see in my workspace, I have an elevation grid and this vector feature, which is a made up trail.shape file. And what I want to do here is to apply elevations to the vertices so that you can have a defined line that's not just 2D, but has 3D values as well. And this line, if you select with digitizer and go to vertex editing and look at the feature vertices, you see there's X and Y values, headings, but there's no Z values. And maybe I have a job that demands getting the Z values or estimate. You could do this manually by updating the elevations from terrain, and that will import, it will apply Z values on this line. But just to show you that you can use a script if you have multiple files that you need to operate on. I've added a script here. I'll just close this. Where I import a file, which is the elevation grid, and then I have the next file as the trail shape. And the command here is edit vector and apply elevations equals yes. So apply elevations is a edit vector command or a parameter that you can find in the reference guide with many other edit vector parameters. So I'll actually open Global Mapper again. I don't know why I had to close that. So I might actually open that data file, those files that I had previously in here. Let's see, scripting data, A1, and also the trails. And I want to run that script in the context of this menu. I see that I've organized these files correctly. So edit vector. So I have a script file here. It's the same thing you saw in the notepad. So I haven't talked about this checkbox at all really in this webinar, but if you do have loaded data and you want to operate, you can check this box to run script in the context of the main view. So already loaded data, you see that it imports this. So I'll just run the script and it updates the vector features. So one of these trail shapes actually has the old data without the elevations. So if I click this and go to vertex editing, that must have been the new one actually. So there's the new Z values with the apply elevation value. So this workflow is mostly just to demonstrate that the scripting commands go beyond just importing parameters and exporting parameters, but also doing work within Global Mapper. So maybe you have someone that maybe isn't too familiar with all of the tools that are in Global Mapper, but you have a script for them that they can run, and just click Run Script. You can get your work done a lot quicker and without digging through tool menus. Just using that simple script to write a couple parameters down and commands can save you some time, and depending on how much data you have as well. So that was just one segue back to editing vectors, but someone did have a question about kind of looping and using scripts based on directories and subdirectories, and I think Mackenzie's going to touch on that in her workflow. So you want to grab the screen back?
Yes, I'll grab the screen back here. And so I'm going to talk a little bit about some more display options you have when importing data. And this first example is going to be importing raster image data and elevation data, and then setting some display options for that imagery. So this is this imagery texture script. I will open this in Notepad so we can take a look at the commands. So for this, we're importing a single file, this elevation.dem, a 3D digital elevation model of elevation data here. And then we're importing a directory tree and importing those same imagery tiles we've seen a couple times already. But for this import parameter, we also have this texture map equals yes, and a color intensity full parameter. And so what those options are going to do is texture the map, so apply some of that hill shade from our loaded elevation layer to our image, and then adjust the color intensity of the imagery as well. Once that is done, we will export the raster imagery, all of those JP2 layers, to a single textured JP2 file. So I will run this outside of the Global Mapper interface, double click to run, and I'll give that a minute to execute. And then go to my output folder, and I should see my image display folder with this texture.jp2, and I can go ahead, just drag and drop to load that into Global Mapper. And we can see here that this is basically the same imagery, but it has some shading applied to it, so that even in this 2D view, we get to see a little bit of what the relief of the terrain in this area is. And that shading has been applied from the elevation data that we loaded. Just to see the contrast, we can go and load one of our imagery tiles from the imagery tiles folder. Any one will do. And we can see that the intensity of the color has been toned down a little bit in our exported image here. And that texture has not been applied to the original image. That is only contained in our exported image. So we'll go ahead and unload this data. And you can set some import options like this for vector data as well. So looking at another script, we can import a shapefile and assign a feature type. So what this does, this is a simple script with just an import command, importing a specific shapefile, and we're setting the area type as state. So that's going to set our feature type. And feature types in Global Mapper are listed for each feature and can sometimes affect the styling and visual style of those vector features. So for this one, I'm going to go ahead and run it in the context of the Global Mapper interface here. So I'll choose File, Run Script, and select script number 5. Make sure I have this checkbox enabled so that the file does actually import into the Global Mapper instance here. And I'll click Run Script. And then using the Feature Info tool, we should be able to see that the feature type for this area feature has been assigned state, just like we specified in the script. So we, from there could go on, do some more vector editing via script or in the interface, or export this to a file as well. So to get more into some analysis functions in Global Mapper script, we're going to talk about generating an elevation grid. So I'm going to unload this data, and for those of you who don't know, this tool in Global Mapper is the tool to generate an elevation grid, and this generates an elevation layer based on any 3D loaded data. So there is a script parameter for that action using that tool. We'll look at this script 17, create elevation grid. And we can open this and see that this imports a point cloud and then simply generates an elevation grid using the units in meters. And there are more parameters you could add to this script command. You can add parameters to specify a spatial resolution or a specific gridding method. A lot of the options or all of the options available in this user interface tool can be specified in the Global Mapper script. And once that elevation layer is created, we export it to the proprietary Global Mapper grid format at this file location. So we can go ahead and run that script. And then take a look for the generated elevation grid in our output folder and load that up. And so now we have this 3D elevation grid that you can continue working with in the user interface or view it in 3D to see that that is a 3D surface, and that was generated from our point cloud using that simple script. Taking this workflow a step further, I will unload this data and take a look at the next script in our list, number 18, to create contours. So this goes hand in hand with creating that elevation grid, is to create contour lines based on that elevation grid. So again, we're importing our point cloud layer, that LAZ LiDAR file format. We're generating the same elevation grid, and then we're generating contours at a specific interval. So we're using the elevation units meter, and we are creating contours at a 1 interval. So every 1 meter will create a contour line based on our generated elevation grid, and then export those contour lines to a shapefile at this directory location. So this one we can run through the Global Mapper user interface just so we see our layers load right away. And we'll see the same script file up at the top. We'll run it in the Open Global Mapper workspace. and that will generate our data. You can see these progress bars running to generate the elevation grid and create those contour lines. So when this creates, we can go ahead and close that script window, and we can see that we have first the loaded point cloud layer, all those individual points, and then our generated elevation grid. This is the same elevation grid as we exported in the previous script. And lastly, our generated contour lines. And these are 3D line features that this script did actually export to our output directory as well. So those contour lines have been exported and saved to a file location. So I do see a question about cropping to a specific area. And we do have a sample script on cropping an image to a specific area. This script here, we can take a look at it to just familiarize you with those parameters. Again, this is importing a TIFF file, in this case, a GeoTIFF. And on the export, we are exporting it to a different file format, that JPEG 2000. And we're using this parameter polygon crop file to crop based on another file. So we're using this circle.shp, this area feature from a shapefile to crop our GeoTIFF while we're exporting it to a JPEG 2000 format. So that's just one method for cropping. There are other variations on this polygon crop parameter, but it can be done through Global Mapper script there. So we're going to move on to another script. It looks a little more complicated. This script 21 in our folder here. So this is similar to a batch export. If you've ever used this batch convert reproject option through the Global Mapper interface, where you can load in multiple files and export them to multiple files, this script is doing a similar workflow here. So we have some comments, as you can see, preceded by that double /. And our first command in this script is to define a variable. So you can use variables in Global Mapper script, and in this case, we are being prompted to select a directory where our source files lie. And this variable will be saved with the name folder. Next, we're prompted to enter another, or to define another variable. This will be stored with the name type. And this time we're going to be entering some text. We have this prompt text parameter, and it will be asking us to specify the output file format. Once we have those two variables set, we're going to use a directory loop to loop through the files in our specified folder, and that is the directory we selected with this first variable here. This variable folder is bounded by those % just to indicate, let Global Mapper know that that is a variable. That's not the name of the directory. It is referencing this stored value. And we're going to import only the .shp files from that directory. We're going to import a file in this loop, and this loop will run through one file at a time. So this will import the first shape file during the first iteration of this loop, and then it will export it to the type that we specify, either KML, GPX, SHP, or another vector format. And then it will unload that one loaded file. at which point this loop will begin again for the second shapefile in the directory and loop over all of the files, exporting those individual input files to individual export files. So to go ahead and run this, I will run it through the global mapper here. And I'm going to uncheck this box, so I'm not running it through the main view. And we're going to click Run Script. So it's prompting me to select the directory with my shapefiles. Now I know we have our scripting data folder, and the shapefiles that we want to work with are in our shapefiles folder. So we're not selecting the individual files, we're just selecting the directory. And even in the script results, you can see that that variable folder has been defined to our specific selected directory. Now I'm going to export these to KML format. I'll just enter that here. And you can see in the script results, it defined our second variable, and then it starts our loop, imports, exports, and unloads, imports, exports, and unloads, and completes that process for every shapefile in the selected directory. And we can go to our output folder. And in our batch folder, we should see all of the KML files exported, one for each of our input shapefiles. So that is a great way to batch convert some files, again with vector files or raster files, and of course within the directory loop between the import and the export, you could load a projection to reproject the files, or change the display, edit the data in some way before exporting that data to a new file or format. So you really can accomplish a lot with Global Mapper Script. You can string a lot of commands together to perform some complex tasks, as well as some more simple ones with just the importing and exporting, either converting file type or a simple reprojection. And we do really encourage you to look into Global Mapper Script and how it can be used in your particular workflow, because it is really great for optimizing that workflow.
Yeah, and I already see a question about scripting pixels to points, and making other data using those results. And yeah, if you use, it's not called pixels to points, it's actually called generate point cloud is the command. And using that, if you go to, I think it's under generate point cloud. Yep. If you click that one, it has all the parameters for the file types you want to load, and all the different types of camera models and quality settings you want, and it defines where you want to output. So it's just another one of our kind of newer tools in the LiDAR toolbar, and you can set up a script to be able to generate your outputs instead of using the interface if you want. And yeah, there's a lot of other questions here that me and Mackenzie will be getting to, within the next week or so. Mackenzie, did you have anything else you wanted to cover for scripting today?
No, we are just about out of time for today. Again, this we didn't by any means hit all of the different commands and options you can use in Global Mapper Script. As you can see with this section of our knowledge base, there are a lot of different options and parameters, analysis functions that you can complete in Global Mapper Script. And we really do encourage you to check those out and even edit some of those sample scripts we shared to apply them to your own data as you begin to work with this function in Global Mapper. So To wrap up, we thank you for joining us today. And if you do have any additional questions after this webinar, as Billy said, we will address the questions you asked during the webinar, but you can always reach out to our technical support team at this email here, geohelp@bluemarblegeo.com, and we will get you some answers to any questions you have on Global Mapper Script or the Global Mapper program in general. So thank you all for joining us today. We really appreciate it.
Thank you.